Now, we will discuss how to determine the density of the geoform. So, this density of the geoform that as per ASTM D16228. So, here main objective of this to determine the density of the geoform, and it depends upon what will be the size of the sample. So, you can make the EPS specimen generally, and this is 50 millimeter. It is a cube, and this also it is 50 millimeter. So, this is the EPS or the geoform, EPS geoform specimen. So, it is EPS geoform specimen. So, this EPS geoform specimen has a particular density. So, size of the sample in the cube form, and this is the 50 millimeter cube. Then what is the procedure, or what will be the apparatus or accessory required for this kind of the test. So, you require apparatus, one is the weighting balance, then vernier caliper, and the testing procedure will be first you determine the weight of the specimen, then you determine what will be the dimension of the specimen, and from this you can calculate what will be the volume of the specimen. So, in calculation that you can write that if rho is the density, rho is equal to W of G divided by V, where rho is the density of geoform, and which can be expressed as kg per meter cube, and Wg is the weight of geoform, that is unit is kg, and V is the volume of geoform. V is the volume of geoform, and that is in meter cube. So, then you have to perform with the defined types of the sample, and you can have the different volume and different weight, and from that you can calculate the density. For an example, I am showing you here that this is the some specimen calculation for determining density of the geoform. So, you take the defined sample number A, B, C, D, okay, and this has a die weight in kg, you know the volume in meter cube and density in kg per meter cube. For example, I am showing one of the sample number, let us say B, and its die weight is 2.434 into 10 to the power minus 3 kg, and volume of the geoform sample is 1.25 into 10 to the minus 4, and this density will be about 20. And you can see here for density of geoform B is density is equal to rho is equal to Wg by B, and weight is 2.434 10 to the power minus 3. This divided by the volume is 1.25 into 10 to the minus 4. So, this will give you the 20 kg per meter cube. Similarly, you can also that determine what will be density under the define the sample and the like A, C and D, and also you can determine what should be the density of the different sample. For example, here for the sample A density is 15 kg per meter cube. For the sample B, as I show you, for the sample B the density is 20 kg per meter cube. For the sample C, density is 22 kg per meter cube, and for the sample this is D, the density is about 30 kg per meter cube. So, there are different types of the density of the sample. So, you have to select that what kind of density of the geoform material required for a specific application. It may be sometimes 15, sometimes 20, sometimes 25, sometimes 30, 32, 40, 42, depend upon the different types of the infrastructure application. So, you know that how to determine the density of the geoform material. This is very important. Next, we will discuss that what should be the water absorption capacity of the geoform material. Because when you are using for the construction of the road as a filling material, or when you are using at the back of the retaining wall as a compressible inclusion, so one should know what will be the water absorption capacity of the geoform material. And water absorption capacity of the geoform material can be determined as per the ASTM C27201. So, here main objective to determine the water absorption capacity of the geoform material. And test of the specimen, here you can see the sample here, that this is 75 by 75 and 12.7 millimeter thick. So, this is water absorption test on EPS. So, this is the sample of the geoform sample, whose size is 75 into 75 into 12.7 millimeter thick, and then you have to place this geoform material into this water. So, testing procedure is 24 hours immersion method, and this is completely immerse the specimen in a container of water for 24 hours. Remove the specimen, shake vigorously, wipe all the surface of water with a dry cloth, and immediately wet and record the weight. So, water absorption capacity, you can write that water absorption capacity like this equation. Water absorption is equal to W minus D divided by D into 100. So, where W is the weight of EPS geoform. So, this is in gram, and D is the die weight of EPS geoform, and this is in gram. So, you know what will be the weight and what will be the die weight, then you can calculate what will be the water absorption capacity. I am showing you one table, and then how you can calculate the water absorption capacity. Here you can see water absorption test result. So, this is density of the geoform kg per meter cube. This is different density 15, 20, 22, 30. So, I will show you only that what will be the water absorption capacity for 20 density. So, this is the dye weight of the specimen D in gram, and for 20 it is 1.322 dye weight of the geoform material, and then you imagine for the 24 hour, and then you weight of the specimen is 1.388 gram. So, then water absorption capacity you can determine knowing the value of the weight and dye weight of the geoform material, then water absorption capacity 3.793. So, here water absorption capacity, as I showed you the equation earlier, this is the weight 1.338 minus this is the dye weight 1.332 divided by this 1.332 dye weight into 100, which will give you the 3.793%. So, this is the water absorption capacity of the geoform material whose density is 20. Similarly, I am shown in this table for different density 15, 22 and 30, whose water absorption capacity may be 4, 3, 2.72. So, it is almost, you can rather say that it is 3 sometimes to 5, 6% of water absorption capacity is varying. And this also very important, that if you perform even then water absorption capacity, the same sample you can find that this compressible inclusion also it is more. And also there is a bouncy effect. So, this density is very important, and one also should know what should be the water absorption capacity of the geoform material. Now, we will discuss the compressive properties of the geoform material. Compressive is very important. You can use on the back of the retaining wall what will be the compressible inclusion. You can use in the cinema hall also sometimes place the geoform block, or you can use geoform block for the construction of the highway using the EPS geoform material. So, what should be the compressive strength of the geoform material? So, this is very important, and one should know how to perform this compressive strength of the geoform material, and we will discuss this as per the specification ASTM D1621110. So, main objective of this test to determine the strength and the deformation property of the geoform material in compression test. So, size of the test sample, it may be cubical specimen, it may be 50, 50, 50 millimeter, or it may be 100, 100, 100 millimeter, or it may be 150, 150 and 150 millimeter. And latest also most of the time you can use 50, 50, 50 millimeter, and it has a certain rate also. And simultaneously you can use this material in the form of cylindrical specimen, and with diameter about 57.5 into 50, or it may be 170 diameter into 50. Here is the just two sample I am just showing here is the cubical, this is the, here it is a cubical, and here it is a kind of the cylindrical. This is cubical 50, 50, 50 or 100, 100, 100, and this is the cylindrical, it may be 57.5 or 50. So, this is the defined type of the sample. So, here compressive strength of the specimen for different density is shown. So, you can see in color it has given because it has a different density. So, this is 15, this is 20, this is 22 and this is 30, and this is in the cubical form, and this is in the cylindrical form with the different density, it may be 15, 20 and 22 and 30. So, you have to determine what will be the compressive strength of the test specimen of different density with unit is kg per meter cube. So, what is the apparatus and accessory required? Compression testing machine, you need load cell, unique LVDT, and you need the data logger for recording the data. So, here we are showing you the compressive test setup. Here is a compressive test setup, and these are the compressive steel plate which you are placed on the top and bottom of this sample. Here it may be the rectangular, here it may be the cylindrical, or it may be the cubical. So, you are placing this geoform sample here by universal testing machine, and then you are applying the load, and if you apply the load, the material will be compressed, and then you have to measure under what compressive stress and what will be the corresponding strain and how the sample fell. So, testing procedure will be that first you measure the dimension of the specimen and place the specimen in testing machine between the steel plate such that load is transferred uniformly to the specimen, and record the displacement and the corresponding load. The test is continue until a yield point is reached or until the specimen has been compressed approximately 30% of its original thickness, whichever occur first. So, these are the testing procedure one has to maintain, and you can draw the different types of the stress strain curve for the geoform material. Now, this geoform compressible inclusion also you can determine as per ASTM C165 or D1621, and cross sectional movement will be 5 plus minus 0.5 this millimeter and per minute, or you can say the equivalent to 10% strain per minute. So, this is important that one should know what should be the strain rate of the machine. So, this one has to maintain, and commonly manufacturing dimension of the geoform according to the ASTM, that is D6817, according to this, the dimension this is all kind of the EPS geoform. Okay? It has a width is millimeter, this is 305 to 1219, okay, and length is millimeter, this is 1219 to 4877, and the thickness in millimeter, this is 25 to 1219. So, this is the commonly used manufacturing dimension of the EPS geoform material. Now, from this test you can draw the relationship between the what will be the compressive stress and the corresponding strain. I will now show you the different stress strain curve for the geoform material under different density of the geoform. For example, here I am showing you that here this is the specimen calculation for the dimension determination of the compressive strength of the geoform material. So, this is strain in percentage and this is stress in compressive stress in kilopascal. And the size of the sample may be 100 millimeter cube, it may be 50 millimeter cube also. So, this is the stress strain curve for a particular geoform density 15 kg per meter square, this is the density. Then next is 20, this is 22 and this is 30 kg per meter cube. So, when the sample size is 100 millimeter into 100 millimeter, 100 millimeter. So, for a particular strain value you can determine what should be the compressive stress. So, compressive stress you can determine at 1%, at the 5% and the 10%. So, depending upon the type of application you can determine what will be the compressive stress, because you know what will be the strain, you know what will be the compressive stress value corresponding to the strain. You can also determine what should be the modulus of the geoform value, knowing the value of the compressive stress and the strain. And alternatively, you can also perform the test in the cylindrical form. So, here I am showing you some result when diameter of this is 150 millimeter and height of the sample is 100 millimeter, this is in the cylindrical form, and here is shown the compressive stress versus strain relation for the cylindrical geoform sample. So, this is the stress strain curve under the different density of the geoform 15, 20, 22 and 30 kg. So, this is you can have a look that how the stress strain behavior of the geoform under the compressive strain, and these are all the unconfined compressive compression behavior of the geoform as a function of the density, as a function of the density. So, I will show you next one typical curve for stress strain curve. So, here it is the calculation for compressive strain, the stress strain curve. So, here is the sitting correction here, and this is the compressive strain and this is the compressive stress value in kilopascal for the density of the geoform is 20 kg per meter cube. So, you can determine for the 1%, you can determine for the 5%, you can determine for the 10%. So, when that it is a 5% strain, compressive strain, then compressive stress of the geoform is 85.5 kilopascal. When it is 10% of the compressive strain of the geoform, then compressive stress is 95 kg per meter cube. So, here this diagram shows the stress strain curve of the geoform cubical specimen of size 100 millimeter into 100 millimeter into 100 millimeter for the density of 20 kg per meter cube. So, from this test also you can determine what should be the modulus of the geocentric material, what should be the modulus of the geocentric material. So, that is also important, because you know that what will be the stress, what will be the strain, then you can determine the modulus value. So, here I am showing this is the stress, compressive stress versus compressive strain curve of a geoform. This is the cubical specimen size is 100 millimeter into 100 millimeter into 100 millimeter of density of 20 kg per meter cube. So, you have to calculate what will be the initial tangent modulus of the EPH geoform. So, here this is the stress strain curve is shown and you draw a tangent here, you draw a tangent here. So, this is the slope of this tangent, this is y, this is x. So, this is elastic limit range between 1 to 2% of strain. So, you know that the slope of this curve will give you the what will be the initial tangent modulus. So, initial tangent modulus E will be equal to y by x. You know what will be the strain and you know what will be the compressive stress, then you can determine what will be the modulus of the EPS geoform material. Next, some more value I am showing it here from this test, and this is the compressive strain test result and the initial tangent modulus of cubical specimen with different density. Here is the density of the EPS geoform. It may be 15 or 20, 22 or 30 kg per meter cube, and size of the sample in all density we have kept constant 100, 100 and 100 millimeter. So, compressive strength in kilopascal at the 5% strain, then it is 60.87 for a density of 15 kg per meter cube, 85.54 for a density of 20 kg per meter cube, and 100.65 for a density of 22 kg per meter cube, and 132.6 for a density of 30 kg per meter cube. Similarly, for the 10%, this strain value is on the higher 68.67, 95 and 112.5, 140. And then you can also determine what should be the yield value. So, yield value for the 15, 55.13, for the 20 density is 82.99, for the 22 density 96.62, and for the 30 density of EPS geoform 124.55. You can also calculate that what should be the initial tangent modulus. So, initial tangent modulus, you know what will be the compressive stress and the strain, because you know under what strain value it is. So, you can determine the initial tangent modulus, you know the what is y, what is x, the slope of the curve. So, for a density of 15 kg meter cube, the initial tangent modulus 2603.08 kilopascal. For the 20 density, it is 4277.25 kilopascal, and for 22 density it is 5796.28 kilopascal, and for 30 density it is 7566.9 density. Here you can find that as the density of the EPS geoform is increasing, the compressive stress value also it is increasing, and at the same time that initial tangent modulus value also increasing. So, here is a question that you know how to evaluate the compressive stress and the initial tangent modulus or second modulus of the geoform material, and when you wanted to use the compressive stress of the geoform material. So, initially you should know what will be the strain value required for the soil, and then what strain value you wanted to adopt for a particular structure. So, if you know that this is the compressive stress value for this particular density is required, I need whether 200 or 300 kilopascal compressive stress value, you should know what will be the bearing capacity of the soil in that zone and what compressive strain value you require for the geoform material. And sometimes also when you wanted to use that use at the back of the retaining wall, so you should know what will be the compressive strain, because in the back of the retaining wall you use the geoform material as a compressible inclusion. So, here you are to be select the most important two parameter. One is the what will be the thickness of the geoform material, that we will discuss later on, and then you should know that thickness of the geoform depend upon what will be the creep value of the geoform material. If you know the creep, displacement, stress, strain, time, temperature curve, then you can determine the what should be the thickness of the geoform required as a compressive inclusion and the back of the retaining wall. At the same time, you should know what should be the compressive strength of the geoform material, because geoform material density depend also on the lateral pressure which is inserted into the back of the retaining wall. So, how the lateral pressure is reduced drastically when you use the back of the retaining wall. Even then sometimes the lateral pressure tends to 0. Thank you.